Good morning and welcome to the latest MEAU webinar. My name is Chris Cusick and today we're going to take a look at how to use Mitsubishi's automation products for load sharing applications. Load sharing is a common requirement for the mechanical handling industry. It can be either an OEM or end user application. We can define it as controlling multiple motors which are mechanically joined together. There are many examples of load sharing. Probably the most common one is a long conveyor line. It is not practical to only drive the load at one point because the driver motor would be too big and the load at one point on the conveyor would be excessive. To avoid these problems, several motors are connected at regular intervals along the load. In a perfect load sharing system like this, all the motors will share the load equally between them, and we will still be able to control the whole conveyor line as though it's controlled by a single big motor. That's fine in theory, but in reality there are many practical reasons why the load might not be even. In this example, a conveyor belt is transporting rocks and muddy debris. The conveyor is driven by a series of motor-powered drive rollers as shown in the picture. Some of the debris sticks to the belt as the belt passes through each pair of rollers instead of flying off, and this in turn causes the load to fluctuate constantly. If we don't do anything, the motor shaft speed will drop and the conveyor will be stretched on one side and start to bunch up on the other side. As well as putting mechanical stresses on the whole system, this will cause the drive current to fluctuate, which may give us nuisance over current tripping. If another motor is constantly being pulled along, there is a risk that the motor will regenerate into the drive and give us over voltage tripping. The Mitsubishi Solution involves measuring the load torque of the system at a single master point and sending a torque reference instruction from a Q-series processor to all the other drives, which can be thought of as slave drives. The master drive is working in speed mode. The speed command to the master will be the speed command for the whole system. The diagram shows the first section of the conveyor, with the speed command being sent to the master drive and torque commands being sent to the slaves. The slave drives will each change their torque output up and down until they match the load that the master sees. In this way, we can be sure that the load is the same at every point and is being shared evenly. To keep the system stable, a Q-series processor is used to perform a PID loop on the torque signal from the master. The slave drives are not trying to run at a specific speed. The actual motor shaft speed is going to vary depending on how much torque they produce, so they're acting in the same way as a slipping clutch would in a mechanical system. We call this torque mode with speed limit. The actual instructions are transmitted via CC-Link, which has the advantage of being fast, robust, and also allowing simultaneous commands to all the slave drives using the group write feature. There is almost no limit to how long the communications chain can be. Each repeater station can operate over a distance of 1200 meters, and up to 10 stations can be supported per PLC. That's 7.5 miles. If necessary, we can set up repeater PLCs as required. Each drive needs to be auto-tuned so that it is correctly set up for its motor. In most cases, RSV open loop control is being used. The auto-tune is usually done with the keypad, since it is something that only needs to be done once. But if necessary, it could also be done over the network. These are the relevant parameters. As usual, it is preferable to do a rotating auto-tune, but for this to be possible, the motor shaft must be completely free to rotate. If there is a load on the motor shaft, for example if the gearbox is already connected, then you should use the static Autotune. Although this is slightly less accurate, the dynamic performance will still be perfectly acceptable for this type of work.